Tony actually had the initial idea, which was world leaders in general, probably mostly speaking in English, but maybe other languages.
I think it's good.
You know, determining, telling the audience in that sort of authoritative, institutionalized type manner, we are in trouble.
And that's much more credible, you see, coming from them, because you know that they've got lots of scientific advice. They've got lots of people that are experts in all the aspects of the various parts of the energy situation that are telling them, Mr. President or Mr. Vice President, this is all we can do. We don't know anything else to do. We don't have it in our fingers to do. It isn't in our hands.
Right.
And yes, you can do a lot with solar cells. You can do a lot with windmills. You can do a lot with several other alternative things. But you can't do the whole job. You can't replace the power grid. You can't replace the coal. You can't replace the nuclear power plants. As long as we have to burn the coal, we have to have the nuclear reactors and things like that, or we have to burn natural gas, for example, or we have to dam up the rivers and have hydroelectric systems. As long as we're in that kind of situation, the energy crunch is going to stay on, because we have to have big power systems to feed a centralized grid system. We have to carry it from here over there to where the consumers are. And if we don't have some better way to do it, the environmental aspects are always terrible, because the more we burn, the more we pollute. The pipelines, everything, the infrastructure that has to support all of that is rarely mentioned, but it's horrific. And when you add that into modern times, where in the old days we expected to remain in a protected fortress, and when we had to go fight something somewhere, we sallied forth out of the castle and we fought it over in somebody else's territory. That day's over. The bad guys are in our own castle now, and when you factor in the terrorism threat to our things like our power grid, the pipelines, the things that are really vulnerable, port facilities where you've got ships loading and unloading and oil tankers and gas carriers. At this point, refineries, at this point you have a tremendous vulnerability, and you have the forces in here who can exploit that whenever they turn the button. So we have a crunch coming at us one way or the other. The consumption need grows every year. Everybody that makes an estimate, although the estimates vary, the need is getting greater worldwide. People don't like to be in the dark. They don't like to not have power. They don't like to have a pitiful life when they could have a better life if they had energy. They're smart enough to know that today most national economy is based on cheap energy. We would hope cheap, clean energy, you see. But the question is, if you don't have at least cheap energy, you can't have the national economy to have a grown-up society and a people that has a decent life, just decent life for ordinary people. And so the needs of the world are just increasing dramatically in energy, particularly electrical power energy. The Chinese culture and civilization today is on the increase in its modernization. Everywhere you look, they're modernizing, which means they're burning more coal, they're burning more oil, they're more competitive for the oil, more competitive for the coal, and contributing a great deal to more pollution. Because when you start early on with coal, for example, the original things you set up are usually not too efficient in burning the coal, and you have a lot more pollution than you do after you put all kinds of scrubbers and things like that on to clean it up a lot. So when a nation is struggling to emerge during that phase, usually they are not as clean with the energy at all as you can be later on when you have more of it and you can afford to put cleaners and scrubbers and things like that on it. So we're already in crisis point in like China and India. All the emerging cultures their demand is going up, is escalating at an enormous rate. And it has to be filled. You simply cannot say we're going to let a large part of the people of the world continue to live in needless poverty and with all of this stuff against them and in very poor lives, because we're not going to allow them to have cheap energy, and we would hope cheap, clean energy. They are going to have the energy if they ever get the culture up to a modern society and have a decent standard of living for a man and his family. You know, put it real simple, put it on the family level and his children. They're going to have a better way and more energy to get the economy up to where there are jobs and where they can have that kind of standard of living and not just all be starving to death and everything. We have, everywhere you look around today, you still find many impoverished people. I mean, utter poverty. I'm not talking about just a little bit destitute. Missed a meal last night. I'm talking about they miss meals almost every night. Or the children are so weak that they can't resist disease. They have little or no medical care. They're famished. They have no medical care. They have no energy. They have no roads. They have no bridges. All of these things that make a society hum and raise the standard of living so that the people live a better life. We really have to do something about that. And the key to it is cheap, clean energy. If we put ourselves in Vice President Cheney's position, suppose for just a moment that we were Vice President Cheney, and we had been given the job of, let's do something that's within our economic ability to do that will provide enough energy to meet our demands. Let's say just for the United States now. So what are we going to do? Well, we're going to turn to our scientific community and we're going to say, what can be done? Our scientific community, unfortunately, is going to tell us the only alternatives you have are the ones you're already familiar with. You can burn more coal, you can build more refineries, you can build more pipelines, you can drill more oil wells. More of the same is all you can do. This leads us to the large centralized power system. The terrorist threat can lay it down anytime it wishes to. There has to be an alternative. The alternative has to come from the scientific community. We have to go back into our models, back into all the equations we've gotten so comfortable with. We've got to look at their assumptions. The way we define our fields in electrical engineering, for example, and classical Maxwell Heaviside electrodynamics, we don't really define the field in space at all. We define the interaction of that field, whatever it is in space, with charge and matter. And it's that ongoing interaction, which is a force field, that we define as the E field, the B field, and so forth. We do not ever define in electrical engineering anywhere the real E field that exists in empty space as it exists. Now, if we go to general relativity or we go to particle physics, we can tell you what that is. But that isn't in the electrical engineering textbook at all, and the electrical engineers are not taught that. If we look at what it is, there is a more fundamental type of field. General relativity has told us this since 1916. Particle physics has told us very clearly since 1930 in the Dirac sea theory. We have an active vacuum, for example, in particle physics that has so much energy in it that in 1 cubic centimeter, by the actual physicist figures, about the size of the tip of my little finger, the energy density in that, the amount of energy that's actually crammed into that little piece of empty space is so great that if I could take that energy and compress it into mass, I would have more mass than the largest telescope can see in the entire universe. So we're immersed in a gigantic ocean of incredible energy density. We know that it interacts with every particle of mass and every charge in this universe. Particle physics already says it does. But when I go to electrical engineering, there is no such interaction at all in the entire science. And so the power engineering uses an inert vacuum. You can't take energy from something that has no energy in your model. It assumes that there's no such thing as general relativity in a curved space-time. Space-time is absolutely flat. Let me give you an example. Suppose you were designing windmills, and you decided you would only design and build and employ windmills where there was no wind, no change in the environment at all. Then you would have to crank the beast around to make it work. So if you design your electrical systems so they cannot ever take advantage of their continual exchange with the vacuum with every charge and particle that's in that whole system, if you specifically design it where it will not do that, you will have to crank the system. You will have to burn the coal and burn the oil and all of this stuff to turn the shaft of the generator and crank the system. That doesn't power the system. What that does, very simply, when you crank the shaft of a generator, its rotation creates a magnetic field. What does this magnetic field do? It doesn't go onto the circuit at all. What it does is it drives a positive charge inside the generator and a negative charge in opposite directions. You expend all of that energy to separate the charges between the terminals of the generator. Now you forcibly separated the charges out there in that circuit and you made it dipolar. And right there is all of the energy that you cranked inside the generator. That's all it does. It doesn't power the first generator or the first electric motor or the first light bulb out there at all. Where the power comes from is like this. If I go to particle physics, in 1957 they discovered and proved this crazy thing called broken symmetry. It was a revolution in physics, a tremendous revolution. It really was. It revolutionized all physics. One of the broken symmetries, and we'll talk about what that means in a moment, one of the broken symmetries is the broken symmetry of opposite charges. That's a dipole. A dipole means you push the positive charge this way, the negative charge is over here separated from each other. That's bipolar or dipolar. If I have the separated charges, particle physics has told me since 1957 that the interaction with the vacuum produces real, observable electromagnetic energy flow out of that dipole. So all I have to do is make a dipolarity, and it will pour out energy from the vacuum forever, for free, as long as I do not destroy the dipole, as long as I leave it fixed. Leave it alone. Don't knock the charges anymore. Leave them just right where they are and freeze them there. That thing will pour energy from the vacuum forever. Who says so? 2 Nobel Prize winners say so. Li and Yang. So, and particle physics says so. But electrical engineering has none of that in it. It has nothing about a dipolarity of the circuit taking energy from the vacuum and pouring it out all the time. So we have a situation where we're using an old model. Nothing wrong with what it did and what it gave and contributed to us. But it's a defective model in today's modern world where we know a dipole takes energy from the vacuum. The electrical engineer never puts that in his model. Never considers it.
And as a result?
As a result, he uses, by the way, a special circuit called the closed current loop circuit. And the whole external circuit, he puts his generator, the dipolarity across the poles of the generator. This external power supply he wires into the circuit as a load for the circuit. Once it collects the free energy that's radiated out of the dipole, he uses half the energy to do nothing but destroy the dipolarity and cut off the flow of energy. We paid the power company to have a wrestling match inside its own generators and lose. The problem is there is another way to do it. Let's talk about it. You have to visualize the difference between potential energy and energy that's actually being dissipated as work. Energy is not work. There is no conservation of work law. By the way, let's make a point very clear that rarely is ever mentioned to an electrical engineer. Suppose I have 1 joule of energy in my hand. I start with. And clever devils that the engineers are that we've been using, we can control this joule. If I take this joule in this form of energy it exists in.
Joule, J-O-U-L-E.
J-O-U-L-E, joule. If I take this joule of energy and I change it into a different form, I have a joule of energy, but I did a joule of work to do that. Work rigorously is the change of form of the energy. Now if I just move the joule over here, I didn't do any work at all. That's just energy transfer. That's regauging. Let's look at that. Isn't that silly? Because what it means is, if I have an energy source that's pouring out energy, As long as I'll take the energy in the form it is and move it over where I want to collect it, I can collect as much as I wish. The simplest equation in all electrical engineering is W equals VQ, where V is the voltage, Q is the charge, and W is the energy you collect on it. From any given voltage source, you can collect as much energy as you wish, as long as you have enough charges to collect it on. The voltage is an energy flow. Whittaker proved that in 1903, 1904. It's a set of flows. So is a field. It's not a fixed thing at all. But the way electrical engineering is taught, when I move it in, if I do, by the way, I want to go back to the conservation of energy. When I changed my joule of energy by doing some work, and I got to use this work to run a motor or something, I still have a joule left when I get through. Now it's just in a different form that I usually throw away and don't use.
Isn't that counter to the general principle currently applied, though?
Sure, because they don't teach the conservation of energy in its correct form. The only thing in the law of conservation of energy says is energy cannot be created or destroyed. That's all it says. It didn't say that 1 joule of energy can only produce 1 joule of work. Let's go through it again. I take my joule of energy, I change its form and run a motor or something, but I collect that joule that came out of there. I don't let it get away. When I got my joule of work, I still got a joule of energy in different form. And guess what? If I still control it, I can now use it, change its form again, and do another joule of work with the same joule. And I'll still have a joule of energy left. There is no conservation of work law. From 1 joule of energy, you can get any number of joules of work if you don't lose control of the energy each time you make a change.
Like heat dissipation is a way in which it's changed form, but then you lose it because the heat is then...
Normally, the way we build the systems, yes, we produce heat and that escapes and gets away from us and we don't recover it. You don't have to build systems that way. One of the things that, we talk about these days is use of negative energy. And it works on the bench. I'm working with a fellow who's got it working on the bench, so it can be demonstrated. You can use negative energy. There are 2 kinds of energy in this world. One is positive energy, and let's talk about positive electromagnetic energy. If I have it going along a line of flow, a propagation direction, positive energy is always trying to diverge. It's always trying to escape from the way it's flowing and turn aside and escape back into the environment. That's normal positive energy. Negative energy is exactly the opposite. If I have negative energy flowing along a direction, the environment is trying always to pour in additional negative energy into the flow and increase it for free. Now, what stops the escape of positive energy or the extra influx of negative energy? It's what we call conductivity. What we call a conductor in conductivity is the ability to prevent change in the energy flow, when you get down to root basis. Okay, if that's positive energy, I don't let it diverge, and so a pure conductor will keep it going in the same line, and if I put in 10 joules here, I'll get 10 joules out there on the end. Normal conductors are not quite pure, so I might lose 1/10 of a joule, or something like that. But I'll get most of it out on the end. It doesn't allow it to diverge. Now, a clever devil that we are, suppose we put in negative energy flow. And again, conductivity prevents the environment from adding more energy. So I get the same energy out that I put in. Again, sounds good so far. But now suppose I have impedances along the line. Resistors, coils, capacitors and all this, capacitances. Every one of those is a decrease in conductivity. What does that do for positive energy? It breaks the ability, reduces the ability of that wire or that conductor to hold it in, and so some of it escapes. And so now when I get back into my real system with the impedances, and I'm using positive energy, at the end I got less energy than I put in because some of it got away. It's the leaky pipe type of thing. I like to call it the leaky diode method. I put some energy in, it leaks out part, and I only get part of it out there on the end to run the load and power things. That's a normal thing that we do. But suppose I put in negative energy, and I have the same impedances. They break the ability of conductivity. They reduce the conductivity, which reduces the ability to hold that energy back, and the environment puts in extra energy at each impedance. And so instead of leaking and losing energy, I leak from the environment into the flow, and when I get out to the end, I have a lot more energy flow out than I'm putting in. Now the other energy is being put in, but it's being put in by the environment along the route. That's the way we'll go eventually.
What generates negative energy?
Real simple. Sharp pulses, for example, that you apply to the vacuum. With the Dirac-C theory, you will lift electrons out of the holes, you'll leave some holes. The hole doesn't instantly have to disappear. The hole can last for a little while.
Well, so to back up, the Dirac-C theory says that an electron lives in the Dirac-C.
The Dirac-C theory says to first order, we can consider this vacuum as being a bunch of little holes like golf ball holes, but each one's got an electron already sitting in it. That's like a golf ball filled hole. So other golf balls can't fall in this hole because it's completely filled. So the electrons flow through that without looking at it. But if I warp the system, I have a sudden sharp gradient. I can pop some electron. The energy that I added can pop some of these electrons out and leave some empty holes. And if I have a part of the circuit designed to use that hole in that form and not let it interact with the matter, it will flow as negative energy. And everywhere I've got an impedance, the environment will add energy. And by the way, it'll cool. Negative energy cools rather than heats. And all over unity electrical systems, taking their energy from the vacuum, all the things that all the inventors have done that take it from the vacuum, the higher the output, the higher the gain that you have in the energy output, the more cooling you have. So you don't have to have global warming and heating if you use a lot of negative energy. But we never teach, you won't find that in a textbook. You will not find anything, any kind of test procedures in NIST for how do you test negative energy hole flow. NIST is the National Institute for Science and Technology, the ones that does all the standards and they're the one that do all the standards and all of this that everybody goes by. You see, by your NIST standards. But you won't find it in any textbook or any of that. But an inventor here and an inventor there has it working in something on the bench that he's still scratching his head and trying to figure out what makes it work that way, because it works backwards to everything that's in his textbook.
How many people do you know about this negative energy?
Certainly there's two. The fellow that I work with who's done it on the bench, it's not my discovery.
I understand.
It's his. And my job was to figure out what's really going on, which after quite a struggle, I was finally able to understand what he had managed to find out how to do was to prevent the holes from recombining with electrons for a little bit and have them flowing while they're still in hole form. So he was actually processing negative energy. By the way, that fellow is John Bedini, as you know. I think eventually, you see, hopefully, if we can ever get the scientific community turned on, so we got young grad students and people like this working on this thing and funded, and nobody destroying their career and letting them do it, you see.
Yeah.
If we ever get to that stage, they'll be working in all of this stuff.
Yeah.
And working out all the mechanism for it. They'll be designing instruments to measure it better and all this stuff.
Yeah.
See, all of that is yet to come, particularly for negative energy.
Yeah.
Because nobody has ever done it before.
Yeah.
Any physicists you know, any academics you know that are working in the...
No, what they do immediately, Dirac himself hated negative energy. See, Dirac himself said, well, you'll observe it as a positron. That's not quite true. After the interaction eats an electron, you'll observe the excess positive charge that's left in the lattice, and that is a positron.
Yeah.
So you chase these lattice positrons around in your circuit, and the people that design semiconductors do that. They are not using negative energy, it's already positive energy.
Yeah.
It's already been converted.
Did they experience this cold phenomenon?
No.
No, they don't.
No, because they're already converted it out of, and it went from negative energy the moment they let it interact.
Yeah.
You only have the negative energy while it has not interacted. Then it becomes exactly what they're teaching in the books. But there's this little hole on the front end, you see. If you can spread that front end a little bit and let it last long enough so the fields, which are negative energy, you can use those, you can get that in a circuit to use.
And a pulse or a warping or twisting of space-time will do that.
That's right.
It's like sort of...
Just, it warps one way, it's
ringing a
positive,
towel.
warps the other way, it's negative. See?
Like ringing a towel.
That's correct.
Yeah.
That's right. I wish we had a DOE or somebody like that now with a tremendous program going, and it's just going like crazy when everything even looks like success. I don't care whether it's us or not. That's got nothing to do with it.
Yeah.
The guys closest to production is John Bedini, that I know of. But there's 2, 3 others out there that also have things that could be produced and could be out there in operating equipment and helping out before we start wiping out the power grid. And that's the problem. There's nobody doing that yet, and they're not going to fund it. Until this election is over, you can forget all of that.
Oh, yeah.
Nobody's going to do anything until they get, whatever the regime's going to be, that takes power after the election in January. You're going to have to wait till then and to wait till they get settled in and all, and then finally here you go again. I was with a small group that actually went out to see John Moray several times, and we were actually trying to work with John. I'll make a long story very short and say John Moray did not get a fair shake on that project.
Did you meet John Moray then?
Yes, I did. This was a government-backed project, which I'm not at liberty to further discuss. But I will say that John Moray did not get a fair shake on that effort. And the effort then dissolved. It should have been a successful effort. The effort dissolved after John detected some tampering with his stuff and material and everything else. So, but the Moray material and the Moray system and everything was absolutely for real. His father really did have what's reported, widely in the newspapers and everything else. He really did have the system.
So
he really had a 50 kilowatt system.
You met with the son, not the father?
Yes, I met with the son. His father was already dead at that time.
Okay.
But John and his brother, I believe, would have been capable of rebuilding that system. I'm quite convinced that John Moray knows how to rebuild it. Okay, so he may not understand the modern physics theory, so what? Yeah, if he knows how to build it and make it work, that's what's important. That's the first order of magnitude of what's important. Then you can figure out the explanation. But I think some things happened that caused that project to fail when it should not have failed. Well, I became enamored of energy from the vacuum early on, particularly when in 1971 I got my master's degree from Georgia Tech while I was still in the Army. I was looking at things like the direct sea vacuum and this kind of thing. You touch on that in nuclear engineering a bit. So you don't get a full-fledged physics treatment of it, but you have to deal with certain concepts like that. And to my surprise, it turned out that the vacuum was extraordinarily energetic.
And you are a nuclear engineer. You have a master's?
Yes, I have a master's from Georgia Tech in nuclear engineering, which I got in the Army in 1971. The Army sent me from 1969 to 1971 to Georgia Tech. I became very much impressed with the idea that here we were in a thing we just thought of as empty space. The vacuum sounds like it's absolutely nothing. And in fact, it was the most energetic thing in the entire universe. It was incredibly energetic. And when I looked into the particle physics that we had to take, it was also acting and interacting with every charge in the universe and every piece of mass. So it wasn't something that wasn't interacting with things. It was generating all the forces that we use to move stuff around and get things done. So think about it from this term. All of a sudden, there's a basic mechanism that generates all the forces of nature. But we're not trying to engineer the mechanism. We're waiting until we get the force, and then we use the force to do something. So the obvious implication is if we would learn to engineer that vacuum flux before it interacts with mass and generates those forces, my goodness, think about what you could do. You could do almost anything in the field of energy and all of this stuff and take it directly out of the vacuum. So that really got my attention. The other thing got my attention was the first time I heard of a Dirac hole, where you've popped an electron up out of the vacuum and left a hole, a negative energy state, I immediately said, fine, and if that's short mass of one electron, that's a negative mass. I don't care what they're saying. It's a negative mass hole, the equivalent of negative mass. You would call it mass energy. And so that thing is going to interact differently with gravity than the normal matter. Because if positive matter gives you gravity, negative matter is going to give you anti-gravity. It'll move exactly backwards. So I was just tremendously impressed with the fact that there ought to be a way to go from the direct sea where you could actually pop the vacuum and lift the electrons out, and those holes in there would then give you some anti-gravity forces that you could use if you could manipulate that, if you could learn how to do that. I didn't have any chance to go any further with it than that, but I had the idea. Years later, working with Floydem Sweetem.
How did you get to meet with Floyd? I mean,
I met with Sweet because I was, in conferences and things like that, and Floyd called me and invited me to come out. And I did. I came out to see him, and he had a 6-watt device at that time working. And I was very much impressed with it because, okay, it was 6 watts, but it was 6 real watts coming right out of the vacuum. There was no way he was faking it or anything else. I could look at anything I wanted to, look at everything he had, every instrument placed, whatever. It was for real. A real 6 watts, 6 little flashlight bulbs lit with energy directly from the vacuum. So he was proving you could take it. So I got into an exchange with Floyd. Later found out in trying to figure out how this thing was working, which I started working trying to figure. You don't figure that out in a few weeks, by the way. That takes a while. But I found that Floyd also had gotten his degree in an older time, and he was unaware of nonlinear optics, which didn't come along and get born, you see, until the 70s. So if you got a degree earlier than that, you didn't get any teaching on nonlinear optics that hadn't been born yet. So I gave him a set of equations and all that. I was standard textbooks on nonlinear optics. Floyd went through it and used that then to understand a little better what he was already doing. And the next unit he built did 500 watts out of the vacuum. The other thing was the unit began, you could tell once we got to 500 watts, the output energy was more negative energy than positive energy. It was a mix. And most of it was negative energy. So all of a sudden comes my realization back from my days there at Georgia Tech. My goodness, we got negative energy holes here. We got negative energy. This thing will do anti-gravity if you push it enough. It has to, or else everything I was thinking all those years is wrong, which could be. But either it's going to produce anti-gravity or I got to change everything I'm thinking. It's real simple like that. So I started talking to Floyd about it, and he weighed the thing, and he said it gets a little bit lighter at 500 watts, and it weighs on the same scale, on the same bench, a good one, when it's not turned on. So I went home and I did every kind of back of the envelope kind of approach you could come up with, wild scheme, whatever you want to call it, anywhere I could find some numbers to get an estimate out of anything. And the best I could look at was if we could push that thing to about 1,500 watts, it ought to levitate. But we didn't dare go to 1,500 watts because one of the other things it did was increase one polarity. It actually deposited what we might say deposited magnetic monopoles inside the magnets, and the magnets would explode if you got too much in there. So we were limited on how much we could push and not explode the magnets and kill the experimenter. So I warned Floyd not to do it, but I got him to build another rear end going up to 1,000 watts. But for God's sakes, Floyd, don't go past that because you're risking explosion. And a magnet exploding from the inside that way is just like a fragmentation grenade. Little fragments all over everything. So he did, and he did the experiment. And I was here in Huntsville on the phone. He's doing the experiment in California, but I couldn't get to California during that time. And he's on the phone reading off the results of the experiments, and I'm writing them down in Huntsville, Alabama. And they plotted the prettiest curve of loss of weight you've ever seen. Was off in the estimates. When we stopped at 1,000, if you projected the curve, it would have crossed at about 1,250 watts. But that wasn't too shabby for just guessing it on the front end. And that was a total guesstimate. But that proved conclusively that he was involving negative energy, and it did have anti-gravity, potential. So at that point, I'm thinking about the thing to do is go to the scientific community with this, let them verify the experiments, everything else. And about that time, Floyd gets shot at with a silenced rifle from about 250 yards or so. And the only thing that saved him, he was old, and as he was coming up the steps when he was fired at, he stumbled and fell down. And just as he was in the process of falling, just as his head was moving, the bullet went right by his ear where his head had just been. Popped the heck out of his ear. No mistaking that sound. But it also frightened the heck out of him. He knew he could be killed at any time. And from then on, he wouldn't discuss the anti-gravity experiment. He wouldn't show it to his investors or anything like that. We did actually get a publication on it. And since it was Floyd's invention, not mine, I put Floyd's name first on the paper, which was totally correct. And so the paper is by Floyd Sweet and T.E. Bearden. It's not by T.E. Bearden and Floyd Sweet. And we did get a publication in one of the engineering proceedings. So we at least did get it reported, but we were never able to follow up on it, and Floyd was mortally afraid to ever go back to it, and so it died right there. He did tell me one other thing, which I did not see, and so I have to tell it very clearly like it occurred. He did tell me later that his curiosity got the better of him. He couldn't resist it anymore. So he hooked the thing up and he pushed it on up towards 2,000 watts, trying to keep it from exploding. And it did levitate, just like it was supposed to. He put it on a tether and then he flew it around the room. He could tilt it and it would develop a thrust. And so that's where he was, and that's when I was trying to get him, let's go to the scientific community. Let's get a couple of Nobel Prize winners in here to look at this. Let's get enough horsepower that the scientific community will sit up and take notice. And this will change science. But it was just not to be. Floyd was mortally afraid, and he may have been correct, that if he'd have tried to done that, he would have been a dead man. So he wouldn't try to do it at all. And that's where he died with the secret of how to completely energize those magnets going with him. I knew about 80% of it, 90%, but I didn't know the whole thing.
This is a yes or no question really, did his fear with the anti-gravity stop him from working on the energy side?
No, he continued on the energy because he felt he was okay there. His energy device, by the way, I'm absolutely convinced, through a very strange set of circumstances, is a takeoff or an adaptation from Gabriel Krohn, the great Gabriel Krohn's negative resistor that he built at Stanford University in the 30s, working on a U.S. Navy contract for a private contractor. They would never let Krohn, who's well known, by the way, in the field. He edited some journals and all this, and he would help produce tensor methods and all that. They would never permit Krohn to fully divulge how he built his negative resistor, which he could power. In those days, we didn't have digital computers yet. And so when the Navy wanted to know about the communication between their ships, they had this huge, what we would call, they called a network analyzer, but what we would call a analog simulator, where they simulated the equations and the signals and everything else and did their signal work this way to find out what would work and what wouldn't. So he simulated everything from Schrodinger's equations to Maxwell's equations, you name it, on the network analyzer at Stanford University, working on a U.S. Navy contract. But he describes in some of his writings that he built a negative resistor, which when you got the current being drawn by the circuit from the power supply equal to the current being put back into the power supply from the negative resistor for the same voltage, you could then disconnect the generator and the circuit was that is the whole network analyzer was self-powered by the negative resistor. Now, he got that past the censors. They often cut him down on when he would try to put it in his papers, but he did get that statement past the censors, and I do quote that in the book, our book, Energy from the Vacuum. So there really was a network analyzer at Stanford, that's well documented. There really was a Gabriel Krohn there, that's well documented. And Gabriel Krohn really did build a free energy system that he called a negative resistor, and he really did run that whole system with it. He had at least 3. And one of his proteges was Floyd Sweet. Okay, Floyd had he did not work directly on the network analyzer problem. He worked on other problems, but he was a very sharp fellow as a younger person, and Gabriel Krohn took a great liking to him. And during the war, Krohn apparently arranged for Floyd to get a master's degree in electrical engineering at MIT. Now, here is where the story gets strange. All those records were later erased for other reasons that I really would rather not discuss in an energy program, and wiped out. So there's no record at MIT of Floyd Sweet ever graduating from MIT. I'm here to tell you that he handled equations very well indeed. He handled the math extraordinarily well. And he had a very fine master's degree from somewhere. I can guarantee you that. And it was MIT. But it was wiped out in some other program that went deep six and underground and everything like that, and went black, and so it got wiped, all trace of it got wiped out. He did not work on that program. But since Krohn was his mentor, Krohn did discuss his negative resistor with Floyd, because he liked Floyd. And Floyd did speak to me many times about Krohn in glowing terms. He really just admired Krohn tremendously. And so I think Floyd's vacuum triode amplifier, which I gave him the name for, I said it looks just like a vacuum triode to me. You're taking the energy from the vacuum, and it's an amplifier because it's putting out a heck of a lot more energy than you're putting in. So the name VTA stuck, and I think that what he did was improved the thing that Krohn had come up with. He probably didn't know all the details, but he knew enough that he stayed with it till he got it to work. And he did produce a 500 watt unit, and later he produced a 5 kilowatt unit, which I never saw. He also produced a unit which was looped so it powered itself with Krohn's condition. Enough feedback, self-feedback coming in to power the thing. When you're putting in as much energy as you have to draw from the generator, you no longer have to draw it from the generator. Let's talk about that, because we need to know what it takes to make a self-powering system. There's no mystique whatsoever. You don't violate the conservation of energy law. For any system to put out more than what you put in, something else has got to put the energy in. The environment puts it in. And I use the analogy of a common home heat pump. You pay to put this much energy in, a little chunk of energy from the power company, and you got to pay for that. No way you can get out paying for that. You pay through the nose for every bit of that. So if that was all that ever went into the heat pump, the only part you'd get out, you'd lose a little bit because every system has got some losses. And you'd get out less than what you put in. That's what you would have, like the standard electromagnetic power system does. On the other hand, if you can get some energy to be input freely or nearly freely from the environment, as we do with the heat pump, we get it out in the form of heat, a whole bunch of excess heat. If you can get extra energy, now I have the environment, let's say, putting in this much energy. I'm putting in this much. So the total input is this big. Quite a bit more than what I'm putting in. Now suppose we have 50% losses, which a normal heat pump is about of that efficiency. This means that the amount that I'll actually get out is about this much. Half of all the energy was put in, because the other half is wasted in the system. That's part of the overhead. But I only had to put in this much. And I got out this much. And that's an over-unity, legitimate over-unity system. But I'm still paying to put in something. But in a common home heat pump, I'm getting out 3 to 4 times as much energy from the system to do work in my home as I'm having to pay for. The environment's giving me the rest of it free. So if I had to pay for all of it, I'd have to double that and pay 6 or 8 times more than what I'm taking from the power company. And if that thing gets to where it can't use the environment for the heat in pump and you switch over to your resistive heating, that's exactly what you do. You start paying through the nose for every joule of energy that goes out of that thing and all the wastage too. And then your cost goes way up and your bill goes way up. But let's go back to the system where I get the environment to put in a goodly chunk. I put in a little bit, and I get out about this much. Still much more than what I'm putting in. Let's say for want of better terms, let's say 5 times what I'm putting in, I get out. The environment may be putting in 10 times, you see. But anyway, suppose I'm putting in 1 part and I'm getting 5 parts out total from the system. If I were to take 2 parts out of that 5 and leave 3 still going out to power the load, and bring this 2 around in a system that wasn't too efficient, it would lose half of it, but I'd get the other part around to replace this part that I've been putting in. That's Crohn's condition. When the equal power input is coming out of the feedback as the same as what the generator was putting in, I can disconnect the generator and it will continue to run. Now, it's not violating conservation of energy. All this energy is being input from the environment. Part of it is going out into the load, and a part of that is being siphoned off and running the overhead of the system itself that you have to normally put in to run the electrical part, you see. That's all a self-powering system is, one that has that feedback loop absolutely governed and controlled so that the system puts out a little bit less power overall, but it now furnishes all of it out of the vacuum. Are there electrical systems that do that? Of course. A common solar cell powered array that drives a generator, drives electric circuits and powers lights and all. It's about, a nominal one's about 17% efficient. It wastes 83% of the energy that it gets from the solar radiation. But the other 17% is free. You don't have to input anything because it's already fixed up to where it uses every bit of that energy to power lights. So what's its COP? Infinity. Coefficient of performance just means the ratio. Take the output, divide it by your input. If you have 0 input and it puts out anything, it's automatically COP infinity. It has nothing to do with the efficiency. It does not violate the conservation of energy law. It's a home heat pump if you were to close loop it. So we want to be sure that you can have a system which does not violate thermodynamics, does not violate the conservation of energy law, but is perfectly capable of putting out more energy than you input, like your home heat pump does, or is perfectly capable of having the environment put all of it in and power that, like, for example, a solar-powered array, a standard hydroelectric power system. You don't put in the river's flow. You don't put any of that in. It didn't say it didn't cost you anything. You got to pay for the upkeep. You got to pay for the maintenance. You got to pay for the dam, all of that stuff. But you don't pay for the energy input. So its COP is infinity. You do not have to pay for the input to a windmill. As long as the wind's blowing, it will turn and crank the generator and power your system. The COP of that system is infinity. The best generator they can build is about 50% to 55, I guess, is the very best that they can build today. So it wastes a lot of energy, but you don't have to pay anything for energy yourself, for the input. You do have to pay for power, for maintenance, for upkeep. You have to build the system and buy it and all this stuff. So it's not completely economically free, but the energy is free. You don't pay for the energy. Floydem Sweetem, in addition to actually having, I'm absolutely convinced, a master's degree in electrical engineering from MIT, was a very sharp individual. I can certainly attest to that. Walter Rosenthal, who is a very fine test engineer, that's the way he made his living for many years. He's a good test engineer, and he knows how to test systems. Walt did see the closed loop system that was self-powering that Sweetem made, and did in fact measure it and touch it and taste it and punch it and look at it, and it was for real and it did work. As we explained, all you have to do is take off the proper amount to replace your input, and the rest of it then continues to be furnished right out of the environment, which in this case is the active vacuum. Floyd was a specialist at designing transformers. He had worked for many years in all kinds of things, but he was very good at his trade. And when he retired, a lot of the companies would still come to him to design their transformers. He could design them a little bit more efficiently and a little less power required to run them and everything, and more stably than most of their engineers. So Floyd got extra consulting work from time to time for quite a while by his ability to design superior transformers. He was a transformer specialist. And in his long years of experience, he had noticed several things. He had noticed some phenomenology with transformers that wasn't in the textbook. And in applying that with some magnets, he had noticed some magnetic effects in permanent magnets that wasn't in the textbook. Let me talk about these effects because now one of them is in the textbook. He had noticed that permanent magnet material, and particularly barium ferrite, was capable of self-oscillation. Now understand, this is way before we had any of the magnificent thin film research that we have going on today and everything. Today, if I say self-oscillation in barium ferrite materials and a few other magnetic materials, it doesn't raise an eyebrow. In the old days, people would look at you and say you were crazy. You can't have self-oscillation in a permanent magnet. You certainly can. And one of the things that so vividly impressed me about his work, one of the first things Floyd did when I first went to see him, he handed me one of his conditioned permanent magnets, barium ferrite magnets, the old audio magnets, the big brick magnets that the audio stores used to sell surplus. He'd go down and buy them out of surplus. And only about 1 in 10 would work right, and usually 1 in 30 would work superbly. He had a procedure where he scanned the surface and looked how much the field varied. If it varied too much, he couldn't use it. It wouldn't hold the self-oscillation condition. If it was particularly smooth and didn't vary too much, it was a candidate that would hold it. So what he did, he found a way to trick this magnet into self-oscillation. Now let's reason together here. What do we mean? Here's the magnet sitting on the table, absolutely still. Nobody's moving a thing. But the field, the magnetic field of the magnet is waving back and forth. And so you can take a shim stock, or if you're out of shim stock, a single-edged razor blade, and put on this permanent magnet, and with a little trouble you can get it to stand up in that field, and you can get it to wave back and forth. And just turn it loose, and it'll sit there on a properly conditioned, sweet magnet. It'll sit there and wave, just like, now it's doing work all the time against the air. I want to point this out. This thing is doing work. So it's getting energy somewhere. We're not violating the conservation of energy law. It's the field that's vibrating and pushing that blade, you see. I took one of those magnets with an oscillating blade on it and put it in the safe and locked it up for 24 hours with it waving. I put the key in my pocket and took it off. The next day, 24 hours later, I unlocked it and it was sitting in there and the blade was still waving. There's no way on God's green earth you can fake that. If you do, you got a trick you really can sell, I guarantee you. But there's no way to fake it. Well, you can see if the field is waving, if I put a coil around here, the field will cut the coil, and standard magnetic theory will tell me I'm going to have current in this coil, oscillating current. But he found if he put the coils at right angles, he could have one that he could control the self-oscillation and create, it was almost like a triode. As he varied on the one that was his signal grid, so to speak, the other coil was a power grid and would dramatically change its output power. So he had formed a very special case of something that could be called a triode. So I said, Floyd, it works exactly like a triode, only you're taking the energy out of the vacuum, and it's an amplifier. So that's a vacuum triode amplifier. That's where VTA came from.
But they weren't using any kind of moving razor blade, were they?
No, you just stuck it on, and it was the field of the magnet that was moving the razor blade.
Right.
But the razor blade was continuously doing work by pushing air. It was fanning the air and doing work all the time. So unless you want to throw away the conservation of energy law, it was getting energy all the time. And so the question then became, how is it getting the energy? Well, there's a peculiar thing about barium in the table of elements. The binding energy of atoms is the nucleons is negative. And if you'll check the curve, you'll find that about the knee of this curve, barium occurs. It's a funny place in the curve that represents the binding energy. So what it means in simple terms is there is a point where if you can get it into oscillation, get that barium atom into oscillation right there at that point, it won't climb up out of this energy well that it's in on the knee of that curve. It may vary back and forth a little, but it'll pretty well oscillate at a given frequency. And by the way, that frequency can be pretty low. It can be 400 hertz or it can be 60 hertz. Sweet could change the frequency by some numbers he had found out how to design. Now, Rosenthal built for him, he had a great deal of trouble with activation. Rosenthal built for him a special circuit that accurately controlled the discharge time when he did his activation. And once Rosenthal delivered that thing to him, Sweet was able to then activate his magnets much, much easier. Before that, he'd bang away for a couple of weeks before he'd get one activated, unless he was real lucky. After that, almost the first bang, he always had it. And he got that precision by some work that Walter Rosenthal did for him. So, but he had found a way to trick that barium nucleus in the barium ferrite magnet into that self-oscillation. And if he had chosen a magnet where it was pretty steady conditions everywhere in the magnet, it wasn't too rough of defects in it, it would hold the condition. And so the magnet would hold that. Now most of them will not hold it. You can get them to activate for a second or two, and then they'll die right out. Later I worked with some people that were able to get activation for 5 weeks, but nobody that I know of ever got activation longer than that except Floyd Sweet. His would stay activated until you gave a mechanical shock or until you shorted the ends. You could tell it was negative energy of the device because when you shorted the output together, it did not get hot and melt. It got instantly cold and ice froze on it from the water vapor in the air.
Would it drive a load indefinitely?
Yes, it
But
would
not
drive a
short.
load. He could light lights, he could drive motors, and he could turn fans and all of that because negative energy is easily turned into positive energy. One way to do it, all you got to do is charge a capacitor backwards. Reverse your leads. Since it's negative energy, it'll still charge it normally. And then you discharge normal energy out of it. It's a piece of cake. Beardenem has shown that with great accuracy. So you can change it back and forth between the kind of energy it is if you get tricky with it. But he was able to power motors, to power lights, and in some of the films and all you'll see him powering lights and fan motors and all kinds of things. And the thing that really intrigued me was when I saw the freezing occur on it and realized it was negative energy mostly rather than positive energy, because positive energy would have got hot and melted, then and wouldn't have got cold. Then, you know, it suggested the anti-gravity experiment, and that one was successful. So I really thought, and I still think, that the loss of the Sweet device was a great loss to the scientific community. So I really hated to see that become lost like it was, and Sweet carry the full secret of his activation to his grave with him.
What was it that was so proprietary about?
How he activated the magnets was the proprietary thing.
So what Rosenthal built for him only took it part of
That was only part of it. There was another part of the activation that didn't depend on the discharge. Part of it depended on heating. You had to heat the barium ferrite to an exact temperature of about 320 degrees Fahrenheit. You had to soften the, what we normally call the, there are parts of the magnet that we consider domains, and you had to soften those domains. They're a little too hard for self-resonance. They'll wipe it out every time. That's the reason you don't get self-resonant magnets from popping them. But if you soften the domains enough and get it just right and get a good magnet that's pretty uniform in its field strength everywhere, you can, if you hit it just right and you do the discharge just right in activating it, you can activate that barium nucleus into self-oscillation. Then you've got a Sweet kinetic magnet. By the way, he also explained that in the old days, a few of the old magnetics guys had stumbled onto self-activated magnets like this, and they called them kinetic magnets. He already knew that it was possible to do that. He had known one or two people who could do it at least a little bit. So there is some, not history, but some folklore experience back to the old guys of a few people who found that you could get magnets to oscillate for a while, self-oscillate. Today, in thin film material and so forth, self-oscillation of magnetic materials is in the textbook. It's not something you got to go reprove. Nobody has thought to use it for power other than Sweet, as far as I know. Everything uses it for something else. But the phenomenology itself of that effect occurring is now in the textbook. In the activation procedure, he did use a coil, at least in the earlier stages after he had the special thing from Walt Rosenthal, so he had precision in his discharge. He also used a center tap coil, but he would never discuss the use of how he used the center tap. So I don't know. That's the 10 to 20% that I don't know what he did. He actually got that barium atom in the magnet to go into self-oscillation, and he got a group, or what we call a non-local or global phenomenon, so that they all got in phase. But that's okay. Self-phasing of self-oscillation is known. And so the whole magnetic field of the magnet was just sitting there and waving back and forth. And you could put a little blade on it and watch it wave. Well, after I got out of the Army, then is when I got into well, actually, while I was still in the Army, I got into some of the visits out to see John Moray. I was very much impressed by the Moray lab and the Moray work and what had actually been, there was no question. Moray had demonstrated this thing literally hundreds of times to all kinds of people that signed affidavits. I mean, very reliable, very worthwhile folks. People that were not foolish or easily fooled. It was not parlor tricks or anything like that. It was real. And a great tragedy is the fact that the Moray device never got developed in this country. That is a great loss to this country because it would have powered the nation. If we go way back, once you get into something that turns you on to this area, you find the history goes on back into Tesla, for example. Tesla certainly did things that electrical engineers will look at this circuit and say the circuit is not doing. If you will look at the circuits, that is actual patented circuits, in what's called a higher group symmetry electrodynamics, covers a lot more phenomenology than the thing that we study in electrical engineering. One of the really fine electrodynamicists in this country, electrical physicist, Terry Barrett, has exactly looked at some of Tesla's patented circuits in quaternion theory, which is much higher symmetry than tensors, for example, or vectors. And so he was startled to find out that the old boy had some tricks up his sleeve. Tesla could move the potential energy in that circuit anywhere he wanted, as he wanted, when he wanted. And this impressed Terry so much, Terry saw a way to improve it. And Terry filed 2 additional patents of the things that he did to improve that. And those patents are still there, and the work is still being used in communications and so forth. It does work. And yes, Tesla did have some tricks up his sleeve that you can't do with electrical engineering. So it goes back to Tesla and his plans to try to electrify the world and give it cheap energy through oscillations in the earth, self-oscillation in the earth. The idea was use one big transmitter, set the earth into oscillation, set up a transmitter antenna somewhere else and take off the energy for free. The powers that be said, well, you can't sell that. You can't put a power meter on it. So the moment Tesla let the cat out of the bag that he intended to donate real cheap, clean energy to the world, Tesla sealed his own fate. From then on, all his trials came to nowhere. Tesla, of course, died in 1943 in his hotel room. Tesla had, for example, done other kinds of inventions, which later people came about and did reinvent. One of them was particle beam weapon. Tesla is the inventor of particle beam weapons. If you look at his actual papers that got sort of smothered, he had that very early on. And today, we know you can do a particle beam weapon. So it goes all the way back to Tesla. And before Tesla, there was an American engineer named Stubblefield. And Stubblefield found out how to take the energy out of the earth and take it out of what's the natural potential. By the way, in electrical engineering, we never calculate the exact value of any potential. Sorry about that, read your book. Because you can always add any other potential you want to the difference. We always get the difference between 2 potentials. Nobody knows what the total potential is. You can take energy from any potential just by making a difference between it and another potential. Let me give you an example. Suppose I have a high power line here. It's at 1,000,000 volts. A little bird comes flying through the air and he lands on that. And his 2 feet, each is both at 1,000,000 volts. The net difference in potential he has between his feet is 0. So he pitty-pats around, sits on the wire, and just has a gay old time. It doesn't bother him at all. Now suppose he picks up 1 foot, and there's a ground wire running right beside it, and he reaches over and sets that foot on that ground wire. So he's got 1,000,000 volts across him. One split and one greasy flash, and the bird is gone. That's funny. He sat on 1,000,000 volts. It didn't do him any harm. He put his foot up with across two potentials, and it just fried him to nothing. So we always get a difference in potential that gives us fields and gives us actually push on electrons and do work and all this. But the actual potential itself is whatever you would like it to be. What is 1,000,000 volts? With respect to some other ground, it's 10 million. With respect to itself, it's 0. So it's the relative difference we always measure. We never measure the absolute value of a potential. It's never been done, never will be done. The common thinking in that line is it's just infinite. You can get as much out of a potential as you want.
What we call ground zero.
Yeah, it's just your zero reference.
It's it's really relative.
So reference potential is all it is. And so, but Stubblefield had found out how to manipulate that kind of thing from the background potentials that are there and limitless, that normally we just see a big zero, almost zero. We'll see, a tiny bit of, 1 volt or 2 volts or something. It can be turned into much stronger currents and power, and he found out how to do that. As a matter of fact, Tesla visited. And there's at least one picture of Nikola Tesla in a group visiting Stubblefield. So Tesla was familiar with Stubblefield's work. And Stubblefield was able to take the energy out. At his death, he was able to cause this energy to light the sky around his place, illuminate the trees. The light would originate in the ground, and the ground would radiate. And when he died, vans and folks came up to his small place, and everything in there electronic or electronic looking got moved out of there and taken. So they buried that one when Stubblefield died. He was back in the late 1800s, and it was all over before, long before we got to the other stage. Then you had Tesla. You had several other people obscurely between Tesla and Moray. The next one of great magnitude that really made the papers and all is, I think, Moray, although you can find a couple of others in there too if you look. And a succession of people came along who found different ways to extract the energy from the vacuum or to take it from the background potential, whatever you want to call it. And in every case, they were suppressed. Moray's thing is not really too clear. I never completely worked out the technique he was using. Part of it was apparently from the Stubblefield type process, an adaptation of that. Part of it was probably independent discovery of T.H. Moray. He did use an antenna, so he established differences in potential. But he was able to, his secret was he was able to build a very special kind of tube. He was building the first, what really were the first semiconductors as far as I'm concerned, before the semiconductor industry ever got born, before they invented the thing. He would grind these materials and make little pellets to go in his tubes. And he had found mixes and so forth that would let him actually get the tubes to take in some of this energy and put out more than he put in. I personally think it was the negative energy I was talking about, but that's my conjecture at the present moment. Give me another 2 to 3 years study on that, and I'd probably work out how the Moray device worked. But I don't have the 2 or 3 years, so I'll just have to let it go at that. But he was taking the energy from the background energy. Now, whether that's the vacuum or whether that's just the gross background potential or what, that's up for conjecture. But there was no question he was taking the extra energy, and his tubes were doing it. And that device that he had at 50 kilowatts, he had something like 29 stages of tubes. What's not commonly known, he built a lot of tubes before he got one to work. Anywhere from 30 to 100. So those 29 tubes represented years of work and effort and everything. And so the story gets really murky at that point because some very special folks went after suppressing what Moray was doing. Moray was fired at. He rode in a bulletproof automobile with bulletproof glass on it. He was fired at off the streets of the city from people in the alley, assassins in the alley. Bullets would stick sometimes in his windshield. Quite a history he had. It wasn't a smooth ride everywhere. And they put some people in to work in his lab, to infiltrate his lab, and one of them beat the machine to pieces once. just heartbreaking, because there is years and years and years of work in coiling all these tubes, and he beat it to pieces. Now, the Moray tube would also do tremendous effects because of the peculiar radiation it had on living systems. And Moray also built medical applications. He got a patent on his medical machines. He was never allowed a patent on his power system, because the patent office would always tell him, you're using a cold cathode and you've got to have a heated cathode, or it's impossible to have energy in a tube. Today we know about cold cathodes. Then they swore that it was impossible, against the laws of nature and so forth. Interestingly, all the files on the Moray thing from the patent office also disappeared.
Oh,
So,
really?
yes. So you won't go find his original applications. They're no longer there. But Moray's unit was real. It worked. It could have powered the whole thing, but they got a guy in which beat it to pieces. The Russians even tried to kidnap him once. He even got to New York on this deal, and he got very suspicious when he got to the hotel. And being a sly old Westerner, he got to noticing how they were talking, and they weren't talking about anything of a project he was supposed to be working on. They were talking about getting Moray and taking him back to Russia. So what happened is he just flat sneaked out of the hotel through the back door and got out of there. But he did have a real device. It really did work. And he did try very hard during his lifetime to get it out, and died without doing so. His sons then later attempted very hard, continuing in the same lab in Salt Lake City, tried very hard to get the system out, and were never able to do so. For one reason or another, everything that came up was sour. And so John Moray, who I think did indeed know how to build his father's device, was never able to get the device out, although he tried very hard. So that device got scrubbed out, and as did all the rest. I point out to you that we've had probably 70 or 80 legitimate devices over the years, starting from Stubblefield, and not a one of them is on the market yet. Now, there's no way you can explain that statistically unless it's absolute rigorous suppression, very strong suppression. Statistically alone, the chances of getting one out would have been far greater than that.
Right. That's a good point.
So there's no problem. It is suppression. To make his special pellets, Moray did another kind of thing in his little semiconductors he made. He pressed them under pressure. If you lock in stress in a little crystalline substance, what have you got? If you got piezoelectric activity, you got stress in, you already got the thing wanting to squirt out electricity. It's just caught in the threshold of the stress. So if you tickle it a little bit off of a defect or something, it can kick out more than what you're kicking in. He also had something that resembled point contact transistor, which was the first one. The point contact transistor was never understood. It was always totally nonlinear. There wasn't a linear place in its whole operation. It was an art to making it rather than a science. And I can show you, textbooks, semiconductor textbooks with these statements in them. And everybody in great relief got rid of that thing when they got to the next stage, which was, putting bands together rather than points. But it always had the capability also going over unity. Every once in a while, this point contact transistor would squirt out more than what you were putting in.
When you say a Moray tube, do you mean like a vacuum tube?
It was a vacuum tube with these pellets in it, in particular 3 things in a particular arrangement in there, very specially arranged and in contact just exactly right, very carefully adjusted. And even so, he would make the tubes, like I say, he might make 30 before he got one to work. He was working right on the state of the art that the technology could actually press these transistors. He would put them in big railway presses, trying to get more pressure on them. And so he was working right at the limit of what he had to work with, which meant it was awfully hard to do.
And he demonstrated it.
He demonstrated it hundreds of times.
Really?
And engineers of all sorts and everything signed affidavits all over the place. Scientists, having seen it, clearly examined it, worked fine, no problem. So the device was real. It worked. We could have never had an energy crisis at all had we focused science. But it was not explainable by the science we had. Much of the physics necessary to explain it, you see, had not yet been born in the 1930s. Broken symmetry didn't come along until 1957. There was no such thing as broken symmetry in the active vacuum that's going to give you power before 1957 in science. The first contact I had with experimenters in this area was with John Moray.
Junior.
See,
Yeah,
when I visited John Moray, and I did that several times, I tried to work with that effort, and of course I wasn't out there. There was nothing I could do to influence it, but I tried very hard to influence a part of the government to do that work that it needed doing very bad. And, you know, to my chagrin, I don't think John Moray ever got a fair shake out of that. I don't think to this day that he ever got a fair shake. I think that was determined that he was not to succeed. He could have done it. Let me put it that way. I'm absolutely convinced. So, but that was just my personal experience where I started. I then worked with a fellow out of Nashville a ways called Frank Golden, and he was interested in the area, and Frank is a good, I'm not a bench person. My job is to figure out how it works once we see the effects going. The last person you want to put on the bench is me. But there are people who are extraordinarily good on the bench, and Frank is one of those, for example. And Frank was building some things which were very, very funny in their activity. And over a period of time working with Frank, we had some very peculiar things happen. The unit that we were working with gradually increased its output. It got more and more, and finally it was putting out 1 2/3 as much as you putting in, even after, even with that, after losses. So you got a problem then. You're clearly putting out more than what you're putting in. So the question is, where is this excess energy coming from? And how is it doing it? What we didn't know, that was a real education, because what we didn't know is it's interacting with the environment, which is the active vacuum in the whole area. And we didn't know you can condition the vacuum. This thought had never occurred to me, or to Frank. And we got into a situation with this thing very successful, working at 1 2/3 out, but we've been working on it about 5 years. And the outfit moved, and Frank wound up moving several hundred miles and moving the outfit, whereupon it didn't put out 1 2/3. The same unit that's been putting out COP 1 2/3 back outside Nashville and grown to that over 5 years, now suddenly doesn't put it out anymore. It's back down like a regular unit. It's still pretty efficient, more than it ought to be, but it's not over unity. The other thing is, it would flash every once in a while and show you it could go back up, but then it would decay away again. On the same project, which was a foundation of a little company that still exists called Astron, one of the people working in Astron and connected with Astron was a very fine scientist, Dr. William Tiller. And Tiller, in the laboratory, with some of his own detection work at Stanford, he used to be the head of the material sciences department at Stanford University, excellent scientist. Bill Tiller had run into this effect of a thing growing over a period of years, its responses, in some of his obscure detector work. So he understood that a system could and would, in some cases, condition its environment to increase its operation. I never thought of that. Like everybody else cranked out of our universities, always considered that environment absolutely inert. Except the vacuum was active with all the particles, you see, that was it. And now all of a sudden we're finding that yes, you can indeed condition the environment. And once you leave the conditioned area, it's not conditioned anymore and the unit doesn't perform as it did. So we found, to our chagrin, we had just wiped out 5 years' work by moving it. Now today we know how to handle that. If we were back there again, you keep it operating in the same place. You build some more just like it and operate them right there so they get up to they're doing their full operation. You gradually move them out towards the edges, towards the outsides in several directions until they're just a little greater than 1, so they go out to 1.5 or 1.2, and you operate them there for a while and let it grow, and then you'll extend that circle faster. When you grow it enough to condition the whole vacuum of the whole Earth, then from then on you can cut it off and cut it on anywhere you want to, and it'll always crank back up. You can grow the reaction of the whole Earth environment itself. We didn't know that.
Do you
And
think
that didn't come from me. That discovery came from William Tiller.
do you think that once it's conditioned, it's a permanent conditioning?
No, all we knew that was it interacted. Now I would go and explain that the background is always fluctuating anyway with curvatures of space-time, and this machine is creating a certain cyclic set of curvature cycling of space-time. And this will gradually, just like charging a capacitor very slowly, this will gradually charge the area with that form, that dynamics. So anything coming along with that dynamics will work better in that environment than it will over here where that dynamics hadn't been created yet, hadn't been charged. It's more like a capacitor charging than anything else, only now it charges with a certain dynamic function. I've always been a person that was always curious, always had a big curiosity about how things work. Always wanted to know how something works. How does the engine in a car actually work? That intrigued the daylights out of me. How does an aircraft wing actually hold that aircraft up in the air? That just intrigued me even as a kid. Maybe another thing that influenced me, I early on started reading science fiction, particularly if you remember the old astounding science fiction days today called analog. During the glory part of its years, there were all kinds of novelties in here, being the editor and other people would put in not only just the fiction, but they would have a fact article. And suddenly you could find out that science had a lot more in it than you had been taught in your school. And science started to expand in your mind based on these articles that were being published about unusual things. So that fired the imagination of any kid that wanted to figure out how things work. Suddenly he found that things can do things you never thought of. So that got me turned on. Really was reading science fiction, and particularly the fact articles that the old astounding science fiction was publishing. Just as a kid, it turned the kid's curiosity on. That's all that happened. My job was always, since I'm not a bench person, you know, I got a BS degree in mathematics with a minor in electronic engineering when I graduated in 1953. But so I did know, you know, basic electronics and things like that, but I didn't know anything about vacuum energy.
What year was the first time you stumbled into one of these free energy devices?
The first one I physically ran into, strong evidence for, he didn't have a working device, but he had the working medical device. You say he had a working tube, was John Moray.
Okay.
And that fired the imagination, because here all of a sudden this had been done. This thing had actually worked. Here were all of these tremendous demonstrations with all of these certificates, and people signed affidavits. And I mean, these were engineers and scientists and people like that who knew what they were looking at. So there was no question, was it real? Yes, it was real. The question was, how does it work?
Because he couldn't really tell.
He was trying to explain it as best you could with electrical engineering, which is impossible because it doesn't have the vacuum in it. It doesn't have a source for the energy to give to you. By the way, let's talk about that. The standard electrical engineering model assumes, as does everybody else, that all EM fields and all EM potentials are made by their source charges. They're produced from the source charge. But in the electrical engineering model, the source charge has no input of energy, but it steadily pours out the energy to make these fields. So the electrical engineer is using a model, and he's never been told that this model assumes, completely erroneously, that every electromagnetic field, every electromagnetic potential, and every joule of EM energy in the universe is and has been freely created out of nothing at all, in total violation of the conservation of energy law.
They're never told that.
They were never told that. It's not in any textbook, and it's a fact. Go check it.
What are they told?
They're not told anything is wrong with their model.
So
They're told a model, to them, your business is not to question this model. Your business is to learn to apply this model and understand it and build these devices we're building now. It's good for that. If you want to build TV sets and you want to build standard motors and generators, it'll do that fine. But it won't get you one extra joule out of the vacuum. The standard closed current loop circuit will deny that to you. No matter if you even build a machine that will do it, it will self-enforce throwing it away.
You mentioned Golden. Did Golden have a motor or a device? What was?
He had a motor that actually put out more than what you were putting in to feed it.
Okay.
It put out more work on the other end of this motor than the energy you were putting into the
So it's
motor,
an electrical motor.
electrical motor.
Yeah.
But it was something gradually built over a period of about 5 years.
Okay.
And what we didn't know is it wasn't the changes so much to the motor that we would figure out you ought to make. We were conditioned in the background without knowing it. We didn't know you could do such a thing. Until we met Bill Tiller, we had no knowledge that the background itself could be conditioned and engineered.
Does William Tiller publish things on this background?
Bill's published on all kinds of things. He's done some of the standard work in several areas. It's a beautiful work that Tiller has done. And he's, of course, a very fine scientist. And certainly was enlightening when we got the stroke of lightning that he had already discovered at Stanford with his detector work, that he could grow the ability of the detector over a period of several years because it affected the environment. The environment fed back. Well, now today, you see, I can very glibly say, yes, indeed, everything you do in the system, it makes a curvature of space-time or dynamics in space-time. And Wheeler tells you clearly that, the system here changes space-time, and the change in space-time interacts back on the system to produce forces. So if you get in a closed loop here, the same thing and all, and you do it just right, if things are just right, and we don't know what just right is yet, it can grow a little bit. And it just amplifies little by little.
Yeah.
You're probably tapping some other dynamics going on over here you don't even know about in the environment. But it does grow, and your system starts to perform greater than what it did. What we had actually stumbled into is what I've started calling precursor engineering, which is nothing in the world but what the Soviets did after World War II, when they corrected these models anyway for the errors in them, and they came up with a science they call energetics, which unfortunately they use for weapons. But you can use it for a lot of things other than weapons. And what you do is you get rid of the force fields in space. You go further to that precursor, which is just a curvature or a twist in space. Or if you're in the particle view, if you love particle physics rather than general relativity, you consider it just a change in the virtual particle flux that's interacting with the particle. So this makes all the forces in the universe. Whichever way you want to look at it, it's the same thing. But now you see your background is active. You see what I'm talking about? The space itself is acting on your unit, and so is, if you're thinking about it in particle terms, so is the virtual particle flux of the vacuum, acting on your system and giving you real effects. And you can use those effects. You can take all the energy you want, if you want to think about it in general relativity terms, out of just the curvatures of space-time is feeding back to you. Or you can take it from the change in the virtual particle flux that you induce, which then interacts back on you to change your system. So you can trigger the actions to give you back a lot more than what you put in. This is the way we ought to be doing engineering. We should not be starting with the forces, so we're always combating forces. If you will engineer the energy first, the energy structuring, that's just regauging. It's free under the gauge freedom principle. Doesn't cost you any work. Now in the real world, you'll have to pay a little bit for switching and control. It's like moving from the leaky diode I mentioned to the triode engineering. Now all I have to pay is for the grid signal. The universe is going to give me the cathode energy flow free. I've got to structure it and shape it to do what I want, but it comes out as a whale of a lot more out of the plate. Then this lot more I let interact with matter, and it turns into real system dynamics and real forces and does big things. You can take a little bit of energy input and do precursor engineering first and shape everything in the triode manner and let go big parts of energy to create huge forces. You don't have to pay for all those forces and all the work from translating the forces. That's the part they really want to hide from you, that you don't have to pay direct for all that energy. You can use the energy for free, take it from the vacuum, build up something which when it interacts with matter then makes very large forces and very large dynamics in real systems. And that's the way we'll go for power eventually. We'll do it with precursor engineering. You'll carry my goodness, you'll carry something the size of your watch around that you can power your home from.
Really?
But we are, 20 years away from that. If we ever get the program started, though, that's where we're going. Now, I point out to you their rationale they use for keeping things like that suppressed. Technology is amoral. It has no morality. The morality is in the hands of the person using the technology. If you have a moral person, the technology is going to be used for moral purposes. If you have an immoral person, the technology is going to be used for immoral purposes. And what we're talking about is cranking the amplifier way up, the amplifier gain way up on everything we do, whether it's for good or for bad. So you see, you got a bad side and you got a good side. It's the old good and evil side that's part of humanity. You see, it's not the technology, it's the human being using it, and there's just no way around that. If you make it more powerful for good, you make it more powerful for bad. The same knife that is great in the surgeon's hand is very bad in the guy that's stabbing you, the robber hand, you see, the same knife. So it's a matter of the person. So when we make a great gain in technology, we make a great gain for the good, and we also make a great gain for the bad. That's the way this world works. Unfortunately, the way human beings in this world work. So far, we hadn't found out how to correct it. Maybe someday we will, but right now, that's the situation. But right now, I'm saying they're already using it for bad purposes. For God's sakes, let's use it for good purposes. Instead of hurting people or working to their detriment, let's try to free them. Let's give them a better economy, a better life, freedom from diseases, freedom from hunger and starving. Do you know how many people are starving? 1/3 of the human population went to bed last night hungry. 1/3 of the human population has worms. Worms! We know how to cure worms, but 1/3 of the human population has got worms. You see my point? We could use the technology for human beings. We don't have to use it to kill humans. I have no compunction and no hesitation in defending my country. Don't misunderstand me. Because I'm a soldier, retired soldier. But I also feel the moral imperative of energy from the vacuum, and this whole area of precursor engineering is so great that we have to use this for the benefit of humanity. It's just so much benefit it can do, it's got to be done.